Ever wondered about the origin of those dark, mysterious spots that appear on the sun's surface? Are they born on the surface, or do they rise from the sun's fiery depths? Welcome to a journey through the cosmos, where we unravel the mysteries of our very own star, the sun. Today we delve into the enigmatic world of sunspots. Sunspots, those dark blemishes that punctuate the sun's otherwise radiant face, have long been a subject of fascination. These shadowy regions are not mere surface anomalies. They are the visible manifestations of the sun's intense magnetic fields. Imagine them as the footprints of invisible magnetic loops with their roots buried deep within the sun's convective interior. These magnetic fields are not static, they churn and roil, driven by the sun's fiery turbulence. Sometimes they become buoyant and rise up like bubbles in a boiling pot. They punch through the sun's photosphere, the layer we perceive as the sun's surface, creating these dark, intriguing spots. But this raises a question that has puzzled scientists for centuries. Do these sunspots originate from the sun's surface, or do they ascend from its incandescent interior? It's a question that straddles the boundary between surface and depth, between visibility and invisibility, between known and unknown. To truly comprehend this, we must venture beyond the surface, beyond the visible. We must delve into the processes that give birth to these magnetic fields and the mechanisms that drive them upwards. We must explore the magnetic dynamo that powers the sun, the convective turbulence that stirs its interior, and the intricate interplay of forces that creates the sunspots. Only by understanding these processes can we begin to unravel the mystery of sunspots. Only then can we answer the question, do sunspots originate from the sun's surface, or do they rise from its fiery depths? To answer this intriguing question, we must first understand the process that leads to the formation of sunspots. So buckle up, for we are about to embark on a journey into the heart of our sun, a journey that will illuminate the dark mysteries of sunspots. The sun, our closest star, is more than just a ball of hot gas. It is a complex network of magnetic fields. This network of magnetic fields is an intricate dance of forces born from the sun's convective interior. Here, the intense heat and pressure generate electric currents, creating magnetic fields. This process is similar to how an electric dynamo works, converting kinetic energy into magnetic energy. But these magnetic fields are not static. They're in constant flux, shifting and changing under the influence of the sun's rotation and convection. This constant movement stirs the sun's plasma, a state of matter made up of charged particles that respond strongly to magnetic forces. As these magnetic fields move and interact, they can become buoyant, much like an air bubble in water. When a magnetic field becomes buoyant, it begins to rise, pushing up through the sun's photosphere, the visible surface of the sun we see from Earth. This process of rising magnetic fields creates loops with positive and negative polarities at their foot points. Imagine these loops as magnetic arches, their ends firmly planted in the sun's surface, with their arch extending out into the sun's outer atmosphere, or corona. It's like a bridge of force, spanning the sun's surface and extending into space. These magnetic field lines above the surface heat plasma in the corona, forming what are known as coronal loops. These loops are visible during a solar eclipse as the bright arcs surrounding the shadowed moon. They are a testament to the powerful magnetic activity happening just beneath the sun's surface. But these magnetic loops aren't just spectacular to observe, they play a crucial role in the formation of sunspots. Those mysterious dark patches on the sun's surface that have puzzled scientists for centuries. These rising magnetic fields play a critical role in the formation of sunspots. So, as we delve deeper into the mystery of sunspots, we must first understand the complex and dynamic world of the sun's magnetic fields. For it is here, in this dance of forces, that the story of sunspots begins. As these buoyant magnetic fields rise, they create loops that pierce through the sun's photosphere, giving birth to sunspots. The birth of a sunspot is a marvel of solar science, a dance of magnetic fields and plasma. It all begins deep within the sun's convective interior. Here the sun's magnetic fields are generated, churning and swirling in a sea of hot, electrically charged gas or plasma. As these magnetic fields intensify, they become buoyant, much like an air bubble in water. This buoyancy propels them upwards towards the sun's outer layer, the photosphere. Upon reaching the photosphere, these magnetic fields don't just stop, they continue to rise, piercing through the sun's surface. As they emerge, they create loops, arching high above the sun's surface. Each loop carries with it a polarity, a magnetic north and south, if you will. One foot point of the loop carries a positive polarity, the other carries a negative. These loops are not mere solar decorations, they serve a purpose. The magnetic field lines that arch above the photosphere are like superhighways for the sun's plasma. This plasma is heated to incredible temperatures, forming what we call coronal loops. But what about those dark spots we see on the sun's surface? Those are the footpoints of these magnetic loops. As the magnetic fields pierce the photosphere, they disrupt the flow of energy. The intense magnetism slows down convection, the process that normally brings heat from the sun's interior to its surface. This reduction in heat makes these areas appear darker than their surroundings. In essence, sunspots are the footprints of the sun's magnetic fields, evidence of their journey from the depths of the sun's interior to the bright and blazing photosphere. They are the birthmarks of the sun's magnetic activity, a testament to the incredible forces at work within our star. But why do these sunspots appear dark in contrast to the bright, glowing surface of the sun? Well, stay tuned as we delve into the dark nature of sunspots in our next scene. The darkness of sunspots is not due to any lack of heat, but rather to a unique interaction between the sun's magnetic fields and its heat convection. Imagine the sun's interior as a bubbling pot of soup. Heat rises from the bottom, reaches the surface, cools down, and then sinks back down, creating a continuous cycle known as convection. Now, introduce a powerful magnet into this pot of soup. What happens? The soup's movement is hindered, slowing down the convection process. This is precisely what happens in the sun. Sunspots are areas where strong magnetic fields emerge through the photosphere, the sun's visible surface. These fields, hailing from the sun's convective interior, behave like buoyant magnets, rising up and creating loops with positive and negative polarities at their footpoints. Above the surface, these magnetic field lines heat plasma in the corona, forming glowing coronal loops. However, the story is different at the footpoints, the actual sunspots. The intense magnetism present slows down convection, the process that typically brings heat from the sun's interior to its surface. This hindrance means that less heat reaches the surface at these spots, making them appear darker than the surrounding areas, despite being at temperatures of about 3,800 degrees Celsius. The dark appearance of sunspots is therefore a paradoxical effect of the sun's own heat and magnetic fields. They are not cold spots, but are simply cooler than their surroundings, because the magnetic fields prevent the heat from the sun's interior from reaching the surface. In a way, sunspots are like solar scars, revealing the turbulent magnetic activities occurring beneath the sun's blazing facade. They are a testament to the dynamic nature of our closest star, a constant reminder that the sun, despite its apparent tranquility, is a seething ball of magnetic activity. So sunspots, despite their surface appearance, originate from the depths of the sun. Sunspots, those dark patches on the sun's surface, take us on a journey deep into the sun's fiery interior. This voyage, as we've learned, is a tale of magnetism and heat, of darkness and light. It's a story that starts not on the surface but deep within the sun's core, where the convection of hot plasma generates strong magnetic fields. These magnetic fields, like invisible serpents, wind their way upwards, breaking through the sun's photosphere, the layer we perceive as the sun's surface. And it's here, at their footpoints, that sunspots are born. These distinct regions, darkened by the intense magnetism that slows convection, are the footprints of the sun's inner activity, a visible sign of the invisible forces at play. Interestingly, these sunspots, despite their dark appearance, are not voids or empty spaces. Rather, they are regions of intense activity. Above the surface, the magnetic field lines heat plasma in the sun's outermost layer, the corona, forming spectacular coronal loops. These, in turn, contribute to the sun's dynamic and ever-changing appearance, a celestial spectacle that has fascinated us for centuries. As we've seen, sunspots are not merely surface phenomena, they are the visible manifestations of the sun's deep-seated magnetic activity, the dark spots on a bright canvas that hint at the complex processes occurring beneath the sun's radiant facade. And so, we conclude our journey into the heart of sunspots, those mysterious dark patches that take us deep into the sun's fiery core. We've explored their birth, understood their dark nature, and traced their journey from the sun's interior to its surface. Remember to like this video if you found it informative, subscribe for more intriguing science content, and share your thoughts about sunspots in the comments below. Until next time, stay curious